All right, let's start out by writing down the definition of the derivative. F must be differentiable, and differentiable basically means that F is continuous and smooth, no corners. Continuous and smooth. Then F prime of X is equal to the limit as H goes to 0 of F of X plus H minus F of X. If I can pull this up a bit. Yeah, that's better. Minus F of X all over H. Well, I can see that I have F of X that was given. Let's write that down. We know that F of X is X squared minus 4X minus 5. We need, for the formula, we need also F of X plus H. So I've got F equals something squared minus 4 times something minus 5. And in all of these spaces, instead of putting X, I'm going to put X plus H. Now I see I've got to square the binomial X plus H. Well, I know how to square binomials. It's the first thing squared. Let's put the formula really quickly. First thing squared, first times second times 2, second thing squared. And if ever you have a negative sign in the middle of your binomial, let B absorb that negative. So if you had X minus 5, let A be positive X and let B be negative 5. All right. Well, so that gives us first thing squared, that's X squared. First times second times 2. I'm going to put the H in front of the X because X is a variable and H is something that can be controlled. Otherwise, we couldn't have a limit on it. So we've got X squared plus 2HX plus H squared. Now, negative 4 times X, negative 4 times H, and a negative 5. So that our formula F prime of X is equal to the limit. And please do write down this limit term every time. I'm going to put F of X plus H in this blue color so that it's easier to see. So X squared plus 2HX plus H squared minus 4X minus 4H minus 5 minus, and let's put F of X in orange. F of X is just X squared minus 4X minus 5. And the entire thing is divided by H. The reason that we go through all of these steps before we can evaluate this limit is that this fraction is not allowed to be undefined. And if h were 0 at this stage, then the fraction would be undefined. So it can't have that. So equals the limit as h goes to 0. Well, now let's look at the lovely things happening in the numerator. In the second part, in the f of x part, I've got an x squared, and here's an x squared, and there's a negative in between. I've got a negative 4x and another negative 4x and a negative in between. I've got a negative 5 and a negative 5 with a negative in between. That's beautiful. Now, before I do any more work, I need to rewrite this so that it's prettier. So I'm just going to write down what's left. 2hx plus h squared minus 4h, and it's all still divided by h. I can see that I have a common factor of h in the numerator, so I want to factor that out. Please show this step. So the limit as h goes to 0, let's use little green. All right. If I factor an h out of 2hx, I've got 2x left. If I factor in h out of h squared, I've got h left. And if I factor in h out of negative 4h, I have negative 4 left. In the denominator, we still have an h. Now we can divide out h between numerator and denominator. But before I start evaluating anything, I want to rewrite this with only the things remaining. So I've got the limit as h goes to 0 of 2x plus h minus 4. Notice that this is the first time we don't have an h in the denominator. So let me see. Can I let h be 0 and still have something defined? And we can. So yay. So we're going to take the limit, which means we do not write that limit down anymore. So we're going to take the limit, and we get, still on the left side is f prime of x, and we're left with 2x minus 4. So now we have a formula for our original function f of x, and we have a formula for f prime of x. The derivative is the formula for the slope of the tangent line to f of x at any x value. Well, the x value that we care about in this problem, they tell us that we care about the x value 4. So let's see. Let's write down what we know. We have x, f of x is x squared minus 4x minus 5. We have that f prime of x is 2x minus 4. The derivative is the slope. The regular function gives us a y for every input x. And now we have the point, let's just say the x value. we've got the x value of 4. So I'm going to take f of x to find the y-coordinate of the point that has an x-coordinate of 4. So I'm going to substitute in 4 for every x in f of x. And we get 16 minus 5, which is negative 5, which means our point is 4, negative 5. To find the slope, of the tangent line, we need to find f prime of 4. Okay, f prime of 4. This will not give me a y. This will give me the slope, m. So we get 8 minus 4, which is 4. So now we have a point, 4, negative 5, and we have a slope of 4, and we're going to use the slope-intercept form of a line. So that is y is equal to mx plus b. The point is my xy. So let's see, y and x. The m is the slope, and I'm going to change its color to this, whatever it is, pink. And then the equation. So I've got the y is equal to the slope times the x plus b. Let's see, so we've got the slope is 4. The x coordinate is 4. The y coordinate is negative 5. And we want to find b. So I've got negative 5 is equal to 16 plus b. Subtract 16 from both sides, and we get negative 21 is equal to b. And that means that the equation of our tangent line is y equals 4x minus 21. And now let's change to Desmos to look at this. All right, there we go. So I've got y equals x squared minus 4x minus 5. The point that we have is 4 comma negative 5. And the equation of the tangent line is y equals 4x minus 21. And now let's make this prettier. Let's see. So I notice, first of all, that it's hard to tell things apart. So what I'm going to do is go back to this side, and I'm going to long press on the purple. And this 2.5 for the width of the line, I'm going to change to 4. And I guess we can leave it purple. Now I'm going to long press on this black dot. I would like it to be orange. And do you see that there's a weight of 8? Let's change that to 15. Now the dot is bigger. And well, this is fine. I want to change the label size from 1 to 1.5. So now it shows up better. And I'm going to long press on the red here. I want this point, this line also to be orange and to be dashed. Now that's better.